the circular array. As always, we set the parameters. And we've got ways of circular array like angle, degree, etc. And then we get a new graphic. The last is the full view. It means you set the size of the plate yourself and fill it with the graphic you draw. So this is how we use array. Now let's get to the group function. We draw another 2 rectangles now. Get them selected and grouped. The outcome tool will get thicker, which means they've become a part with fixed cutting sequence and their position relative to each other will stay unchanged. On the contrary, it can be degrouped into 2 original graphics. And to group a grouped graphic also can be realized. And that will demand degroup twice accordingly. First, we get them grouped and get all the graphics grouped. Now they are grouped. Sometimes we need to cut lines of small circles. Let's draw some graphics first. Now this is the normal cutting path. But on the right of the group, we have this fly cut feature, which enables us, instead of repeating the process of starting and finishing, which comes with a lot of speed changes when processing small circles, to maintain the same speed in the whole process. First, we select all the graphics. And click Fly Cut. Make sure the distance valid, and we get fly cut paths. Now this is more efficient. The same applies to rectangles. Get them selected and fly cut. The fly cut feature can be cancelled by D group if we change the plan. It can be degrouped. And what is co-age? We combine to generate a shared age between parts with an overlap age, so that to eliminate unnecessary cutting path. SipeCut supports co-age for rectangles without rounded corner. After we select the graphic and click the icon, there will be 5 ways of co-agent to be chosen. Let's take aspartame for example. We recommend overcut as default setting. Then here we got a more efficient, effective solution. And when we want co-age parts with inner contour, let's draw a new graphics. If a rectangle with a circle inside, we need to get the graphic grouped first, and then do the array and co-age. To finally generate the optimized cutting paths. This is how we use co-age. Like we've mentioned that the nest just provided in the basic level in SipeCut, so is the co-age. If you would like more choices, check our website below. Our software application SipeNest is rather professional. When we cut a part formed with several pieces and with closed loop, typically the number and the letters we may need to bridge it. For instance, if we got the number 0, and the letter D, if we don't get it bridged, both of the round and the ring would fall down, and only leaves a single hole on the metal sheet, which wouldn't be satisfying. To fix that problem, first we select the graphic, switch into curves, and click bridge. Hold left button to draw a line across 2 cutting paths. Here remember to make sure the distance between the 2 lines be within the effective distance, or you may fail to get one. Now we get our bridge line, and we can click the measure to manually measure the exact distance between lines, like this. And the figure will appear down below in the drawing bar. So this is how the bridge line works. Now let's come to the last feature. If we don't want paths get automatically optimized when input, click Manually Optimize. In the drop-down menu, we have this break grid, which is used to cut up the inner waste so that to avoid it going up and getting in the way of the cutting head. Now let's draw a new graphic. Now we use this break grid, and normally we use grid mode and set one line for meridian and latitude respectively. And then we have the grid line. So guys, so much for today. We've learned the ways of sorting, how to use array and group graphics, optimize the cutting path with flycut and co-edge, measure and bridge, as well as optimize graphics. Try doing some practice. See you next time. Hello guys, nice to have you back. Here is Frenda's sidecut tutorial. So far we've learned about features in view, geometry, technique setting, which enable us quickly draw graphics and set basic techniques. This sort, group, flycut, and co-edge help us to simplify cutting paths to be efficient. Today we're gonna learn a few more features of layers, task, and fine edge, as well as how to use machine control panel. Let's start with the machine control panel. First of all, we need to figure out the difference between floating coordinate and workpiece coordinate. Machine coordinate is a fixed system. To facilitate flexible cutting tasks, sidecut applies floating coordinate and workpiece coordinate. Direction definition in different coordinate system is the same. The only difference is 0-point position. The white box is machine bed, and the red cross is laser head. On the floating coordinate, laser starts cutting from where it stands. 0-point is current position of laser head. Take this position. We can start right from the point. And if we move to another position, it will start right from it. Floating coordinate usually used in small batch cutting task. Under workpiece coordinate, we've got a default 0-point with its position 0, 0. But 0-point is a user-defined position under workpiece coordinate. Sidecut allows user set 9 workpiece coordinates of different 0-point. During the process, if the cutting head was moved to other position, so long as it gets an instruction to start, it will return to the graphic that next to the defined 0-point, and then start cutting. This coordinate used in mass production scenario that a large quantity plates of same size placed in same position on machine bed which also requires a 0 point of fixed position. Down below, with this button,